Number 4 is going to be from the section talking about double angles and half angles. Now the first 5 things that you're going to fill in for this problem are the same as we did before on the previous test. So the previous test we just had to fill those 5 in. We are going to do the same thing here, but now we got these extra ones. So first of all, what we have to do is we need to draw the triangle in the correct quadrant. And then we're going to use Pythagorean theorem to find the third side. We'll have enough information to do the first 5, so we'll start with that. Now we're given that cotangent is equal to negative square root of 2, and we're given that cosine is greater than 0. Now your tangent would have exactly the same sign as cotangent would. So we want to find the quadrant where tangent is negative, but cosine is positive. So if we take a look at our all students take calculus, all students means everything's positive, that wouldn't be it. Students means that sine's positive, everything else is negative. No, that's not the case we have here. Down below here, take represents tangent. Tangent's positive, everything else is negative. That's not the right one, we want tangent to be negative. The fourth quadrant, we would have calculus represents cosine, so cosine is positive, everything else is negative. That would work for what we have here. So that's the kind of logic you want to think about when you draw the triangle. So it's going to be drawn in the third quadrant. Here is your theta measured from the x-axis. We're given that cotangent is negative square root of 2, which we can represent as negative square root of 2 over 1. And your cotangent would be adjacent over opposite. So we still have to make sure we know the definitions for all the 6 of the trig functions. And just remember SOHCAHTOA, that will tell you the relationships between those, and cotangent would be the reciprocal of tangent. So that's how we got that, adjacent over opposite. Adjacent would be this side here, and opposite would be this one. Now the problem is written this way with a negative out front of everything. So we have to choose which one's going to be negative. And that's going to be this side right here. So this side is going to be square root of 2, and this one we're going to make negative 1. So again, that's going to be the adjacent over the opposite. Now we're going to use Pythagorean theorem to get the missing side. So a squared plus b squared equals c squared. In this case, the c would be the unknown. Okay, so a and b, we have square root of 2 squared plus negative 1. You're squaring the negative, so the negative is inside the parentheses. You'll get 2 plus 1, which is 3. And then you're going to get plus or minus the square root of 3 is your value for c. So let's put that plus or minus here. Now the hypotenuse is always going to be positive no matter what. So that's going to be positive square root of 3 that we'll have for that one. Okay, so now we have that the triangle is complete. We're ready now to fill in the blanks here. Alright, so sine is equal to opposite over hypotenuse. Negative 1 over square root of 3. Now for this problem, it doesn't say anything about rationalizing. Okay, so if it doesn't say anything about rationalizing, then don't worry about it. Now on the answer key I have for this, I do have it rationalized, but for this case here, because I have limited space, I'm not going to show the rationalizing steps on it. But if you want to do that, you just multiply top and bottom by square root of 3 over square root of 3. And you rationalize it. So I'm just going to keep it in this form. If we flip that, we get negative square root of 3 for the cosecant. It would be negative square root of 3 over 1, which would just be negative square root of 3. Next, we're going to do cosine. So cosine is equal to the adjacent over the hypotenuse. And so the adjacent would be square root of 2 over square root of 3. So I'm just going to put square root of 2 over square root of 3. Again, you could rationalize it also if you wanted to. I'll leave it like this. Reciprocal would be square root of 3 over square root of 2. Next, for tangent, we're going to take the reciprocal of cotangent, which in this case is just going to be negative 1 over square root of 2. So the first 5 things is pretty much going to be review. So again, on my answer key I rationalized all these, but I'm going to leave them in this form when I work this through. Now, for these other ones, sine 2 theta, cosine 2 theta, I need special formulas for those. So you want to make sure you know the formulas for the double angle and half angles because you need to use them here. So I'm going to now erase this since we have all the information that we need to fill out the rest of these. Now the first one we want to do is sine 2 theta. Okay, so sine 2 theta is equal to 2 sine theta cosine theta. There's only one formula for sine 2 theta. The sine and cosine, we're just going to grab those directly from our answer that we did previously. So for that, we're going to put in 2 times sine, which is negative 1 over square root of 3. Cosine is going to be square root of 2 over square root of 3. You're going to multiply across the top, across the bottom to get your answer. And in this case, if you multiply, this is 2 over 1. If you multiply across the top, you get negative 2 square root of 2. Across the bottom, square root of 3 times square root of 3 is just 3. Okay, and that would be your exact answer for sine 2 theta. Negative 2 radical 2 over 3. Okay, so that's everything for sine 2 theta. Next, let's do cosine 2 theta. So I'm going to erase this. And we want to pick a formula for cosine 2 theta. Now cosine 2 theta actually has 3 different formulas for it. So it doesn't really matter which one we pick. So here's one. We have 2 cosine squared theta minus 1. That's one of the 3 identities for that. There's also 1 minus 2 sine squared. There's also cosine squared minus sine squared. So I'm just going to choose this one. We're going to put in our value for cosine, which is square root of 2 over square root of 3. We'll put that in here. So square root of 2 over square root of 3. We're going to square that one and then subtract 1. We get 2 over 1, and then that would be just 2/3 because that would remove the 2 radicals on the top and bottom, minus 1. And then you would just get, if we multiply this out, 4/3 minus 1, which is 3/3. So 4/3 minus 3/3 will give us 1/3. So the answer is just regular fraction there. It's going to be just 1/3 for cosine 2 theta. Now, in the notes, I did give you a formula to do tangent 2 theta. That involves a 2 tan on top. You know, we have that formula. But if you're confident with your answers for sine 2 theta and cosine 2 theta, you can actually just simply divide these two answers to get it. And so that's what I'll do for the next one. We're going to do tangent. We're going to use this formula. Tangent 2 theta is equal to sine 2 theta over cosine 2 theta. So I'm going to use that particular identity. Okay, so I'm going to just put both these answers in. I'll plug both of them in for sine 2 theta and cosine 2 theta. So if I put that in, it's going to be negative 2 radical 2 over 3. I'm dividing this by 1/3. If you flip and multiply, what will happen is the 3's are going to cancel out, and you're just going to get negative 2 radical 2 for your answer for tangent 2 theta. Negative 2 radical 2 we get for that one. So now we have those. We have all the double angles complete. Now we're ready to move on to the half angles there. Now for the half angles, the formula that we had in the notes for that involves a plus or minus in that. So when you put your answer for this, you do not want to put your answer and leave it as a plus or minus. You need to determine which quadrant it's in. So what quadrant theta over 2 specifically is in, and that's going to tell you whether you're going to use a positive or a negative on that formula. Now, in order to determine what quadrant it is in, we're going to look back at this initial information. We determined that this was going to be drawn in the 4th quadrant. So because it's the 4th quadrant, that means that you would have this. So you would have your theta is between 270 and 360. So that was the original information that we drew the triangle in to get these first 5. So now we want to find theta over 2, what quadrant it's in. To do that, we're just going to divide everything by 2. And when you do that, you get 135 theta over 2, and you get 180. So this says that your theta over 2 is between 135 and 180. Now if you look at the quadrant it's in, that ends up being in quadrant number 2. So now that we know what quadrant it's in, we want to determine, is the sine value in the second quadrant positive or negative? And then the answer would be positive. So you would say sine theta over 2 is positive in quad 2. Okay, because that's the quadrant we're in. We're in the second quadrant. If you use the all students take calculus sine chart, it tells us that sine theta over 2 is positive in quadrant 2. Because it is positive, now we know how to write our formula specifically that we'll use for sine theta over 2. So that one is going to be, so we have sine theta over 2 is equal to positive. So again, I'm not using plus or minus, I'm using the positive version here. 1 minus cosine theta over 2. So that's specifically the formula that I want to use. No plus or minus, I determine it's positive. Next, we want to put in the value for cosine, which is square root of 2 over square root of 3. So we do that, it's going to be square root of 1 minus square root of 2 over square root of 3. And all that's going to be over 2. So I'm just putting that value into there. I need to simplify this, so I want to get a common denominator. The common denominator on the top would be square root of 3, so I'm going to multiply the 1 by square root of 3 over square root of 3. And if we do that, without showing you all the work for that one, I'm just going to show you the result we get here. We get this. So we multiply by root 3 over root 3, combine them together as a single fraction, and we get this. Now the last thing we want to do is flip and multiply, so that all this actually is still underneath the square root. You're going to take the top fraction, multiply it by the reciprocal of the bottom one. And if you do that, you're going to get square root of 3 minus square root of 2, all that over. So when you think of this, you're going to really think of that as multiplying that by a half. So you flip and multiply. Multiply across the bottom, you're going to get a 2 square root of 3. So again, we just multiply by 1/2 to cancel out that one. And so then we get this here as the exact value. So put that in here, square root of 3 minus square root of 2 over 2, so we're done with that one. Now the tangent theta over 2, I did give a formula in the lecture notes that has a plus or minus in it also, but you don't have to use that one here. We're just going to use one of the other two formulas that I gave you for that. And if you use the other two formulas that do not have a square root in it, you don't have to worry about going through this and trying to figure out what quadrant it's in. You don't need to worry about that. Whatever sign you get, or plus or minus sign you get as a result of using that formula, then that's going to be your answer. You don't have to make any other adjustments. The formula in particular that we're going to use on this, we're going to use tangent theta over 2. The one we're going to use is sine theta on top, and we have 1 plus cosine theta down below. So this one is one of the two alternate formulas I gave you that doesn't have the plus or minus in it. And there's another one that we can use as well that has sines and cosines, but we'll just use that one. So in this case, we'll put in, we don't have to worry about any plus or minus signs. We're just going to put the signs in exactly the way they are. So in this case, we're going to put in on top negative 1 over square root of 3. On the bottom, I have 1 plus cosine is square root of 2 over square root of 3. And like the last one I did with the sine theta over 2, I want to get common denominators on the bottom. The 1 I'll multiply by square root of 3 over square root of 3. And if I put that together over a single denominator, I get this as a result. Square root of 3 plus square root of 2 all over square root of 3. Now, last thing I want to do is flip and multiply this. So when I flip and multiply, this is what I'm going to get for the result. I get negative 1 over square root of 3, and I multiply it by square root of 3 over square root of 3 plus square root of 2. And in doing that, I'll get the square root of 3's to cancel, and I'll get negative 1 over square root of 3 plus square root of 2. So again, this looks a little different than the answer key, and that's because I didn't rationalize it. If I were to multiply top and bottom by square root of 3 over square root of 3, I would get the same answer that is in the key that's right here. But in this case, I'll just leave it like that, negative 1 over square root of 3 plus square root of 2 there. So again, don't worry about if there doesn't say anything about rationalizing. then don't worry about it. However, if it does say find the exact value, that means you do not want to use a decimal. So if it says find the exact value, that means you want to make sure that you actually use all the square roots in there and express it as a fraction or square root if necessary.